Hi, the SI meteorologist Paul Dorian here on Monday, February 10th. A lot to talk about today. We have a major East Coast storm threat coming in the Wednesday night, Thursday time period. Last night there was another snow event here in the Mid-Atlantic region with 2 or 3 inches of snow throughout the Philadelphia metropolitan region. I think 2.7 was the official tally at the Philadelphia International Airport. Little less than that to the north in the New York City region, even less in the D.C. region. And in fact, the Philadelphia metropolitan region has really been the bullseye over the last several events. Last night's snow accumulation reached its peak in the southeastern part of Pennsylvania, the Philadelphia suburbs. Last Monday, about 10 inches of snow fell in the Philadelphia suburbs. Again, the bullseye for the snow. And of course, the ice storm had its worst impact in the southeastern part of Pennsylvania last Wednesday, partly as a result of the bullseye of the snow accumulation totals last Monday. So lately, Philadelphia has been kind of a magnet for the most snow and ice, and we'll see if that continues for this potential major storm on Wednesday night and Thursday. Well, let's take a look at some of the models. We have several models to look at for the Wednesday night, Thursday potential major East Coast storm. One thing I want to point out, some of you may have heard that over the weekend, Tokyo, Japan received 20 inches of rain, a big storm, one of the biggest storms in years in Japan. Why do I bring that up? Oftentimes, a deep trough in the far east translates to a deep trough in the eastern U.S. several days later. So there's a good teleconnection reason to believe that there'll be a major East Coast trough later this week. This is the European model forecast for Wednesday evening at 500 millibars. And sure enough, it shows a deep a trough here in the south central part of the country, headed towards the East Coast. A lot of upper level winds, a jet streak associated with that deep upper level trough. And again, this is quite believable given the current nature of the deep trough now out over the Pacific Ocean. Again, that from a teleconnection point of view often translates to a deep trough along the East Coast several days later. Let's now jump ahead 24 hours. This is a 24-hour increment from Wednesday evening to Thursday evening. And here you go from last night's European model run. Closed off low here at 500 millibars, a very healthy looking East Coast trough system, somewhat of a negative tilt here with strong upper level winds rotating around the base of that trough. In other words, the potential for a major East Coast storm according to last night's European model run. Again, totally believable given the current pattern out over the Pacific Ocean. Well, let's now take a look at the surface map from last night's 0Z European model run. By Wednesday evening, significant low pressure here over southeastern part of Georgia. Notice the high pressure area causing some cold air damming down across the Appalachians. Cold air in place. That high is moving a little bit off the coast, a little bit more than you would like to see for a classic snowstorm. We'll have to keep that in mind over the next couple of days as this progresses. But again, a major low pressure area here according to the European model in the southeastern part of Georgia. Let's now jump ahead 24 hours. And here is the European model forecast for Thursday evening. 24 hours later, it jumps from off the Georgia coast, rides up the East Coast to a position just off the Mid-Atlantic coastline. A major storm here predicted by the European model run. Now, the rain-snow line is obviously always of crucial importance in terms of determining snowfall accumulations, and there certainly is potential for that to stay east of the big cities, allowing for primarily snow from D.C. to Philadelphia to New York City all the way up to Boston. And this kind of a storm has a potential for a foot or more of snow in the I-95 corridor. But that is another thing we'll have to focus in on the details of over the next 24 hours or so, if the next couple of days, if in fact there's a mixture on Thursday with the snow mixing with sleet or freezing rain. That obviously will have a big impact on snowfall accumulation amounts. Well, let's now take a look at some of the American computer forecast models. By the way, those European model forecast maps were from the College of DuPage website. This is the NAM, North American Mesoscale model for Wednesday evening. It too has a very impressive upper level trough here in the south central southeastern part of the country come Wednesday evening, and that looks similar to the European model run. Let's now jump ahead 12 hours. And here's the forecast map from the NAM model run last night, 0Z model run for Thursday morning. And again, a very healthy looking upper level trough here, going somewhat negatively tilted, very similar to the European model run. This, as well as the European model run, suggest a major East Coast storm. Now let's take a look at the NAM surface map forecast for Wednesday evening. Low pressure, again, it's kind of similar to the European model run. And notice this typical rain snow line here. At this time, Wednesday evening, just south and east of the DC metro region. And also notice a high pressure, not exactly in the best position for a major snowstorm here in the I-95 corridor. Again, we'll have to monitor this over the next few days. You'd rather see the high pressure up back here over southeastern Canada. Instead, it's off the East Coast, and that could allow for that rain snow line to back into the I-95 corridor. Let's now jump ahead 12 hours. Here's the forecast map for Thursday morning. Significant low pressure area right along the East Coast according to the NAM model run. Now notice that rain snow line does back in here to the I-95 corridor. It's a close call here, and that'll be, of course, very important in terms of potential snowfall accumulations on Thursday. Any kind of a mixing on Thursday in D.C. or Philly or New York City obviously could cut significantly on the snowfall accumulation amount. So we'll monitor this over the next couple of days. Any shift in the track, of course, will have a shift in the rain snow line as well. Now let's take a look at the Canadian model run. This is from last night's 0Z forecast model run, and then we'll finally end up with the GFS, which is kind of an outlier here. This is for Wednesday evening, the Canadian model run from last night. Let's step through this on an hourly basis. Snow breaking out at this time Wednesday evening in the DC metro region. Let's go hour by hour here and watch what the Canadian model does. Very significant snow falling at this time. This is the middle of the night, Wednesday night, Thursday morning. Low pressure just off the southeastern Virginia coast. Snow moving into southeastern Pennsylvania. And the rain snow line, according to the Canadian model, kind of hanging along the coast southeast of the D.C. area. Let's now step ahead. This is now a Thursday morning time frame. The low pulling off the South Jersey coast. Still snowing across D.C., southeastern Pennsylvania, New York City, and now moving into the Boston metro region. So the Canadian model keeps that rain snow line just to the east of the big cities. It comes very close to the D.C. metro region, but still, in general, primarily a snow fall from this system, according to the Canadian model run Wednesday night and Thursday. Finally, let's take a look at the GFS model. Well, here's the 0Z GFS model run for Wednesday evening. We're starting off with the same 500 millibar pattern. Notice, not quite as impressive of an upper level feature. In fact, it's somewhat positive tilted compared to the other models we looked at that had a negatively tilted and a stronger upper level feature, 500 millibars. Let's now jump ahead 12 hours. And here's the forecast map for Thursday morning from the 0Z GFS model run. It does have an impressive wave, but certainly not quite as impressive, not quite as negatively tilted as the other models, the Euro, the NAM, and the Canadian. Now let's take a look at the surface map. And here's the surface analysis forecast map for Wednesday evening for the from the GFS model run. Low pressure a little bit farther to the east compared to the other models as of Wednesday evening. Remember the European model and the NAM had the surface low a little farther to the south and west in this region here, so quite a difference here between the GFS and all the other models. Let's now jump ahead 12 hours. And here it is, the outlier, the GFS, with a storm well off the East Coast with minimal impact along the I-95 corridor, especially when compared to the other models. I believe, once again, we're seeing a southeastern bias with the GFS model. Given the trough situation right now over the far east of the Pacific, I believe there will be a significant trough here in the eastern part of the country with a major East Coast storm in the Wednesday night, Thursday time frame. I believe the GFS model will pull this system closer into the coast as we get closer to the event time. It often has a southeastern bias with the storm track along the East Coast, where it starts off 3, 4, 5 days ahead of the event time with the storm a little bit too far to the south and east. And again, that is very likely to back in towards the coast as we approach event time. So it does look like a major East Coast storm. The question that remains is the rain-snow line. Will that back all the way into the I-95 corridor and have an impact on snowfall accumulations? The one thing going against a all-snow event is the positioning of the high pressure over the northeastern part of the country. It shifts off the coast rather than where you would rather see it in southeastern Canada or anchored in New England. Can still get a all-snow type of storm, but it makes it much more difficult. So we'll monitor these details over the next couple of days. Stay tuned to the SIWeather.com. It'll be an exciting week coming up. That's it for now. I'm meteorologist Paul Dorian.